Do you have link.exe?
No.
No. Link? Link?
Nope.
No. Okay, we'll continue. I don't know how many pages.
Yep, up top.
Yeah.
All right, link.exe, so it's there. So the link is at what?
PIN.
At the PIN.
Uh-huh.
This, make sure. So this is at what? PIN file. Right? And this is at the PINR file. So now what do I need to do? That .obj has to move from bin to
PINR.
BINR in order for me to link. I can't link the file if it's not residing in this environment, right? So the command for this, you say move. I mean, we could go from BINR CD. We're here. We could say move lab3 dot obj. That's supposed to be in bin, right? It's in bin, correct? So no, the lab3 dot obj is in bin, correct? Right? dir. You see it is where? It's in bin. So I'll say move lab3 dot obj space to sex11/BINR. I'm already in bin, right? So I want to move lab3.obj space to ma611/BINR. So put it in that directory. Move that file from bin to BINR. How do you know? If you hit enter, you see a space between the two action lines. It means you've done it correctly. If you made a mistake, it will say illegal coding. So if you misprint, if you mistype, you gotta write move space the file space to that environment C:611/BINR. So now if I go to bin, I should be able to see my lab3.obj. Now we could link. So the file is already in what? In the BINR, where the link action residing, right? So now I will link lab3.obj. Program does not have an error, so automatically it will produce what? Those extensions. Here we go. We'll say link lab3.obj. Okay, so it gave you lab3.exe, .map. Okay, we done. So now what do? The system already produced lab3.exe and already produced lab what? The file.map for it. Well, interested in the exe. I take that exe file, now I run what? Debug. So I will say debug. Before I do this, look at dir, and you will see your lab3 dot what? .exe created. Lab3.exe created. That takes us to debugging. Debug lab3.exe. Okay, now we're in debug. What is the first code all the time you have to do? Right there. I created the lab for you very clearly. You have already lab last week. Don't lose it, okay? Because I have no problem answering you all the time, but it becomes a problem. After a couple of lectures, you keep asking me what's next, what's next. It means you're not doing your job. Okay, I don't want to make it sound like that. So I'm giving you the procedures to, believe me, this you'll be able to generate any .exe file. And you challenge anyone in computer information systems. Because you have the ability right now to produce .exe. So you can run it on your operating system. Okay, so we got this. The first code is unassemble. We want to make sure what is the IP value assigned by the processor for my data. Right? The first code, if we go back to our program, the first code was move what? Move AX comma data segment, right? And then move DS comma AX. But the first code was move AX comma data segment. So we want to know what IP value has been assigned by the processor for the data segment. When you say unassemble code segment colon 0 to 1, the first code segment. Remember when you did debug, you said unassemble from 100 to 10F, right? Until INT3. Here, I only want the first instruction, because the first instruction tells me what value, what IP value has been assigned by the processor to dump in the data in. So we write it the way it is. The way it is. UCS colon 0 to 1. Unassemble code segment 0 to 1. The first only. The first. And when you do this, that value is what? The data segment is assigned the value of 0C, 0B. My data at the data segment field. Remember my data segment field? It says data 1 DB 25. Next, data 2 DB 1F. Isn't it? Next, sum DB question mark. So now we know the data segment starts at what? 0C, 0B. I will dump this to see if my data is there. So next, so unassembled code segment 01 will what? Will show the will show the IP address for your data. So what is the IP address? 0C0B. Clear? So now I'll dump 0C0B from 0 to F, the first 16 byte, from 0 to F, and this is what I wrote right here. Okay, dump IP value that you're gonna get from this system. So rely on this is for that particular program. Every program will have a different IP value for the data. So now this will show the data 0F. So you have what? 25 and 1F. Remember we said data 1 dB 25. Data 2 dB 1F. So they will go up right after each other. So when you add them, 15 and 5 is 20. 20 minus 16 is 4. Add 1, 3, 4. So the answer should be 44 in the next, because the sum came right after the data. Right? So when I run the program G, I run the program, I dump again. I should see what? I should see 44 right after that. So dump 0C0B from 0 to F, and here we go. The sum is 44. Okay? So this way we have a map. We have that structures, and we did it in front of you to see what's going on. I'm gonna adjust a little bit the program to discuss couple of the directive, which is extremely, well, I mean, we do use them a lot, and one of them is the origin. Used extensively, so common directive. We said mnemonic are split into what? Split into, the mnemonic is split into, right, Mr. Eric, go back to your note. Split into instructions and directives. Instructions will produce what? Machine code. Directive will not produce machine code. Directive just tells the processor, how it should organize things. Common directive, like the assume statement, the block for, block near, segment, end segment, right? The one that we use in the program. DB, defined by DB, DQ, DT, DW, like those directives. Common directives will be assume, block for, could be DB, DW, DQ, DT, we gave you these, and now also we have the OR, that's for the origin. Very powerful, very powerful. I might, if I need to keep my program organized, I will have my I will have my data in one place, one block of line, and my result in the following. So here, 0f, 0, 0, 0, f, what's the next one? 1, 1, 0, right? 10, right? 0, f, next will be 0, 0, 1,